done lots of concrete with this as well. Because it is for the lab, we wanted to know the graph. So the movement of this, it goes very slowly. The graph will be generated. It also measures the displacement when it's applied the load in a step way. Now let's start it.
Let's start it. Guys, where's
We have to know to start it or to know only how to break the beam?
We're just showing in a note, you will be okay.
What do you call this machine, sir?
Compression machine.
Compression machine, yeah.
Compression machine, and the name of the company is this one.
Compression wood machine, right?
No. Okay,
For
this
all.
one is can
Steel,
break
huh?
anything. Look at the frame. This can take 3,000 kilonewton.
Yeah, for all.
So
Yeah.
if the whole building collapse, you can safely stand under this. You will be safe.
Support.
So this section can replace the steel section?
This one?
here? No.
It can, but it doesn't take the same load as a steel. So we put a X to go. We have a choice. We go for a position, means displacement. Y we go for the load, and
Yeah, that's
we are
not
going
X.
to save the data, and we make it on 0 position 0. We don't have a transducer. Transducer, sometimes you want it to, so here it will tell us how much is the deformation right in the middle of the beam.
yeah.
But sometimes for a research, you wanted to know how much is the formation there,
Yeah.
or how much the other side. We are using the transducer. It will tell us the formation at any point of
As
the.
a sensor, yeah.
It's a sensor.
Yeah, okay.
It's measuring at any point. But here we just wanted to see the maximum. So the one in the middle, it is enough. We will save the data. And today was 6th December. So we call it the I-beam test 1. And this is for the commercial purpose also. You can give an ID number, so we call it I-beam
Sender side.
test 1. And then who is tested this state, that is doesn't need.
Comments, no.
The sample size, it will be good to know the height of the beam, because the height of beam is affecting the second moment of area. The taller it is, it can take
You
more
know,
load.
or I will measure it.
We can
Measure
so
it.
just measure the height, 300, and the flange.
It is 7 something.
7.5.
7 something.
7.
So it is 70 by the 300. The weight doesn't matter, we know the weight. So now we are ready to start. And you may want it to be little bit away when it is breaking maybe the pieces it might come. And we go. Still it didn't reach to loading it. So that ramp, it can come up 10 centimeter, and it is more than enough to break this. And now I started to take the load.
What is suddenly break, yeah?
It will be a sudden break, yes.
Come one straight line that it is on time.
Yeah, and so it will be good to be a little bit away from it. So far we have around 22 kilonewton and it's gone.
Yes, done.
The web is gone.
Very
The web is gone and load is coming down, so that means it's finished basically.
Collapse.
It is not. If you want to take the photo of the graph and then share it with others.
No?
It is failed completely, but it didn't go the flange, the web went. And that's why it shows like this gradual failure.
So at 22 kilonewton,
Turn it is.
It
That would be
reached
the
it
maximum.
reached around 22.7 peak load.
This means Doctor not
Because the timber didn't go, the web went. The reason this was in a lab for the storage for many long time. It is twisted. It is twisted, so it's a torsional failure. It is not a flange failure. Theoretically,
So
the timber should go. But if you look at it from the side, it's a torsion failure. The web is failed rather than the timber.
Okay, torsion.
It twists.
Twist.
It twists. Why? Because a long time it's been in the storage.
Maybe, doctor, it is because it is thin, it is too twisted.
Say it again.
Because it is thin, not too much thickness.
Because
for that, and the height of this
no,
web.
it's happening because it's a timber. It does twist. It does twist.
And for example, if it is this one more thickness, it will not twist.
If it was more thick, yes, you're
I
right.
think like that because it is the thin of the wood. It's make it twist.
That's correct. Yes.
Ready.
so how much does this cost one span?
It's cheap, maybe 50 pounds.
Per
Yeah, the maximum, 50, 60 pounds, depending on the thickness of the flange. It's quite cheap compared to the other.
Other, yeah.